Hello! In this video we will take our first look at objects. I will start at a conceptual level and in a follow-up video move over to Java. Let's begin here with this object. An object in programming is often used to model some real-world thing, and that's where we will start. An object has a name for better identification of what type of object it is. This particular object is a rectangle. Objects have what we call properties or attributes, information about the object. These properties also have names or identifiers. My rectangle has a width and it has a height. It could have a property called area and it might have a color. So for now my object has a name to identify the object type, which is rectangle, and my object has 4 properties: width, height, area, color. Let me just move things around. Here I have another rectangle. Given that this is also a rectangle, it has the same properties as the first rectangle. However, clearly the values for those properties are different. Let's put in the values for the first one. I think the width looks like maybe 8 and the height is maybe about 5. That gives the rectangle an area of 40. And finally the color, that's blue. I could be specific with nuance of blue or provide the color as an RGB code, but I'll keep it simple. So the color here is just blue. Now for the other rectangle it has the following values. The width and height look about the same, let's say 6. The area is then 36. And color may be burnt orange. So what we have here is the object type of rectangle. I am showing 2 different instances of rectangle. These objects have the same properties because these are the properties of a rectangle, but they each have their own specific property values. So this here is the template for an object type called rectangle. When you have an object of type rectangle, it has certain named properties. I can then create instances of this rectangle object type. These instances can have different values for their properties, or multiple instances can have the same values but still be different instances. This is another object. It also has a name. It's a circle. And similar to the rectangle, it has properties, though different ones. This time we have diameter and circumference. We could define more properties like area, color, radius, and so on. You get the idea. Let's try a slightly more different object. Here we have a coffee cup. For this cup, we could define color, white. We can include whether it has a saucer or not. And the content, which clearly is coffee. And let's add a property for temperature in Celsius too. Again, I have an object with a type and properties for such a specific type. When I have guests over, I'm going to need multiple instances of coffee cups. And because I scavenged them in a second-hand store, they are all different, meaning all cups have the same properties, but the values for each cup may differ. Now let's look at the second part of objects, behavior. In programming, we generally express behavior with methods. All object types have a name, and all object types can have properties, which is information about the object. Each property has values, and these values may differ between different instances of the same type of object. And finally, the behavior. In the real world, objects can do something, or we can do something to the object. Let's start with the rectangle again. Now, this type of object may not be able to do much, but let's say we can stretch the rectangle horizontally by a certain factor. I might define a behavior called stretch horizontally. And I need to be able to tell it how much to stretch. For example, stretch by a factor of 0.5, basically halving its width. I will indicate that by providing an argument to the stretch horizontally behavior like this. So to my object template over on the left, I will add a section for behavior. Let's call this section methods. I could define another method, say display area. Notice the parentheses here are empty to indicate that this method does not require any extra input to perform the behavior. Whatever display means in this context is maybe not clear. If it was a real world rectangle, maybe there would be a display or something, maybe a speaker, I don't know. In your program, displaying information would likely go to the console of your IDE, probably IntelliJ, or later some user interface. Let's return to the cup again and have a look at how we can define the template for this particular object. We have the name and we have the properties too. And now let's consider the behavior of my cup. I might be able to fill it with content, so let's define a method for that. And I need to define what the content is. To keep it simple and somewhat programming oriented, I will just say that the content is a string, which is then the name of the content, coffee, tea, hot chocolate, whatever. And another operation, maybe we can sip from the cup. Clearly I had too much time on my hand here. For the sip method, I define no arguments. The method does not require any data to work with. I could maybe define the size of the sip or whether to first blow on the hot content, but I just keep it simple here. So to recap, objects often model a real-world concept. Not always, as you will see when you progress through the course, but this is where we start. Each object type has an identifier, a name. The objects can have properties, 0 or more, and objects can have behavior, defined as methods, also 0 or more. I think that's enough concept for now, so let's stop here.